The diagram shows a graph of f of x, for f of x is equal to 6 plus x minus x squared. The point P a half 25 over 4 is the maximum point on the graph. Okay, so here we have our function. We know it's that way around because we've got minus x squared, and we've got a maximum point or a half at 25 over 4, so it's 6 1/4. It says determine whether f of x plus 2 minus 4 has any real roots. If so, write down their coordinates, and then write down the coordinates for the maximum point of the graph of y is equal to f of x minus 3 plus 2. So, if we sketch the graph of y is equal to f of x plus 2 minus 4, so the x plus 2 bit means that's a translation, a horizontal translation minus 2 units to the left, or a horizontal translation minus 2, 0. And the minus 4 is a translation downwards, minus 4, or translation 0, minus 4. So, if we take some points, but we have to be careful, one thing is that the y-axis is represented here, that represents 2 units. So if we take that point, and we now move it back 2 units for this translation, and then down 4 units for that translation, that will take the maximum point to there. And then if we take some more other convenient points, like this one here, and go back 2 units and then down 4 units, don't forget that's just going to be two squares on there. That will take the that point to a new root, which is going to be at minus 3. And similarly, this point here, if we go back 2 units and then down 2 units, then we're going to get another point here. Now we could move the roots, the original roots as well, so down, back 2 and down to here, and the same here, 2 down and then 4 down, sorry, 2 to the left and 2 down and 4 down. And again, we could do that some other points. Then we could join that point up there, and this will be a graph of the translated function, this. Okay, we can very clearly see that it does cut the x-axis. This is what we need to determine. And these 2 points here are the roots. So we've got one root at minus 3, 0, and another root at 0, 0. So y is equal to f of x plus 2 minus 4 has real roots minus 3, 0, and 0, 0. Now for part B, we've got y is equal to f of x minus 3 plus 2. So this is going to be a translation 3, 0. Even though it says minus 0, it's actually going to go to the right, horizontal translation 3 units. And this is going to be a vertical translation 0, 2, so it's going to be a translation upwards by 2 units. So here is my original graph. Here's my maximum point. So this point is going to move along 3 and up 2. So that means I need to add 3 to that coordinate and 2 to that coordinate. So that's going to be, which we're going to call P dash, half plus 3, comma 25 over 4 plus 2. So the maximum point is going to be a half plus 3, 24 plus 2. So this point is going to move to this point here. So that's going to be, this is going to be 7 over 2, and this is going to be 33 over 4. So 8 1/4. Okay, so that is the maximum point, and therefore we have answered the question. Now, if we wanted to just sketch this transformation, we just need to move a few points. So, so 3 along, 2 up. And again here, 3 along and 2 up, and then we move some other points, 3 along and 2 up, 3 along and 2 up, and then we can move some other points, and we can get the curve of y is equal to f of x minus 3 plus 2. We just need to make sure that we move each point here 3 along and then 2 up. So this is the sketch of that particular transformation. We weren't asked for that, we were just asked for the maximum point. Okay, so this has been a video to look at the translations of a quadratic function. I hope you've understood, and I thank you very much for watching.